So let's take this example. So beginning with the first one, we have 0.4573 multiplied by 0.6834. That's our number one. Now, first of all, remember that when you see multiplication in logarithms, it simply translates into addition. So once you write out their logs, you add those powers. It's basically the opposite of indices. In another class, we'll treat indices. So once you see multiplication, it signifies addition. So we're going to use our table to solve this, and it's very easy. You have your number here, and you have your log on the other side. So we'll draw a line. So the first digit, the first number we can see here is 0.4573. Okay, so we're going to find the logarithm of 0.4573. So we reflect it here, and then we'll find the logarithm of 0.6834, and we reflect it here. Then we add the powers because multiplication signifies addition. So what's the logarithm of 0.4573? We go to our calculator. Our first step, how many leading zeros are here? Just one. So we have bar 1 point. So we are now looking for the logarithm of 4.573. Log 4.573, and that gives us 0.6602. 0.6602. Remember, you're only taking the mantissa, you've already gotten your characteristic. And then the next one, we still have 10, that means bar 1 point. So we are looking for the logarithm of 6.834, and that gives us 0.8347. 0.8347. So the next step is to add. Now you've gotten the powers, that is the logarithms. So you will now add it up together. So 2 plus 7 gives us what? 9. 0 plus 4 is 4. 6 plus 3 is 9. 6 plus 8 is 14. We're going to carry over 1. Now, before we add that our 1, let us add these two negatives here. So minus 1 plus minus 1, that simply means minus 1 minus 1. And that is minus 2. So remember the 1 we are going to add, that means minus 2 plus 1, and that still gives us minus 1. So we have our minus 1. So this thing called bar 1 is actually negative 1. But remember, this negative affects only the characteristic. It doesn't affect the mantissa. So now, this is the result of your addition, but that's not the final answer. The final answer would now be when you find the anti-log of this one, the anti-logarithm of this one. And how do we find anti-logarithms? First, all you need to do is look for the anti-log of 0.4949. And when you find the anti-log, your characteristic is going to determine how many zeros before the point. So let's look for the anti-log here. We have, so the anti-log of 0.4949, that gives us 3.1253. So let's stop at 3.125. But when you're looking for anti-log of a number that is less than 1, you're not going to capture the point. It makes it easier for you to write your actual answer. So we have 3.125. So I'm just going to write it as 3.125. Notice I didn't need to put the point. So the next thing is, I'm going to ask myself, what's in the characteristic? That's bar 1. This indicates just 1 0. So I'm going to put a 0 here, just 1 0. And right after that 0, I'll put my point. So the answer to this is 0.3125. So if you took your calculator and you punched in it 0.4573 times 0.6834, you're going to get 0.3125. Let's take example 2. So here we have 0.0516 divided by 0.632. So we have our number here and we have our log. So the first one, 0.0516, and that is divided by 0.632. 6.32. Now, just as in the case of the first one where multiplication signified addition, in this case, division signifies subtraction. So we are going to be subtracting this from this once we get their logarithm. So what's the logarithm of 0.0516? First step, how many leading zeros can we find here? That is 2. So we have bar 2. Point. So we are now looking for the logarithm of 5.16, and that is log 5.16. So that gives us 0.7126. So 0.7126. Okay, next 0.632. How many zeros here? Just one. So that's going to be bar 1. Point. So we're looking for the logarithm of 6.32. Log 6.32. And that gives us 0.8007. 0.8007. So the next step, we're going to subtract now because it's a division. So the division indicates subtraction. 6 minus 7, it can't go. So we're going to take 1 from here and add it to 6, and that becomes 16. 16 minus 7 gives us 9. So we have 1 left here. 1 minus 0 is 1. 1 minus 0 is 1. 7 minus 8, not possible. So we take 1 from here to this place and it becomes 17. And 17 minus 8 gives us 9. So when you take away 1 from minus 2, what's left? Minus 2 minus 1 becomes minus 3. So we're going to be having minus 3 here, minus 1. And minus 3 minus 1 simply means minus 3 plus 1. And that gives us minus 2. That is bar 2.9119. So we're going to now look for the antilog because we're done with this operation. So we look for the antilog of bar 2.9119. So what we're looking for right now is the antilog of 0.9119, and then the bar 2 determines how many zeros before the first digit. So let's look for the antilog of 0.9119. So the antilog of 0.9119 gives us 8.164. 8.164. Again, remember I didn't need to put the point because this will determine where my point will be. So the next step is how many can we see here? This is bar 2. That means 2 zeros. 1, 2. Naturally, our point is going to be here. So the answer is 0.08164. 0.08164. So that's the answer to this. And the third example is more interesting. So we have the cube root of 1.376 divided by the cube root of 0.007. So we're going to still solve this on our table, but we will probably have another column so that it will make our work look neater. So it's very easy. So the first thing we'll do, write our number and our log. Okay, so we have a table here. Most likely we're going to have a third one. Right. So let me explain this. Just as a reminder, according to the law of indices, okay, I could also rewrite these questions as 1.376 raised to power 1 over 3, all divided by 0.007 raised to power 1 over 3. So the law of indices states that if you raise a number to this power, the denominator becomes the root, while everything is put in a bracket and raised to the power of the numerator. So it's the same thing. But here in logarithms, what it means is that we are going to divide the log of this number by 3. Because that's like you're multiplying this number by 1 over 3, according to logarithms, which is the opposite of indices. So we're going to be dividing this number by 3. Otherwise, you're multiplying it by 1 over 3, which is the same thing. So the first step, we're going to write 1.376. So what's the logarithm of 1.376? Log 1.376. I'm punching this directly because it's a number that is greater than 1. So there's no need of writing the bar. We just put it directly into the calculator, and that gives us 0.1386. 0.1386. So this will be divided. Let me increase my column. So this is going to be divided by 3. Now the next one is 0.007. So this number is less than 1, and we can see the leading zeros here are 3. So that becomes bar 1. So what's the logarithm of 7? The logarithm of 7 is 0.8451. 0.8451, and this will be divided by 3 as well. So whatever answers we get, we reflect it here, and then we perform the operation of division, which is subtraction in logarithms. So let's find out first 0.1386 divided by 3. 0.1386 divided by 3. That gives you 0.0462. Okay, this is easy, straightforward. But now you have bar 1.8451 divided by 3. So we are going to go to our rough work now. Just imagine this is going to be our rough work and see how we can work this out. Okay, so we have bar 1.8451 divided by 3. Now, first off, I mentioned it earlier that this negative here belongs only to this one. So in cases like this, it must be treated separately. So we are going to be dividing -1/3, and then separately we're going to divide 0.8451 by 3. And that, when we get the answer to that, we bring it back together. Now, I explained to you earlier that the reason this minus is placed on the top is to make an emphasis that the minus belongs only to 1 and not to the fractional part of this logarithm, which is the mantissa. So we're going to treat it this way during this division. All right? So whenever the characteristic part, the digit there is not the same as the number that is dividing it, you are going to handle it separately. So how do I mean separately? You know, if I decided to have -1/3 plus 0.8451/3, if I decided to add them together, I'm still going to get -1.8451 divided by 3. So I'm going to treat it this way. But there's still another problem. This is -1 divided by 3, and this is 0.8451 divided by 3. It's easy to divide this one, and it will still stay the way it looks. But if you divide this one, you're going to get decimals. But now we don't want to get decimals in the characteristic part. We still want it to just be a whole number, a single number. So what do? We're going to perform an operation now that will change the appearance of this, but not necessarily the value. So what do? Now remember, if I say -1 plus 1, that gives me 0. If I say -3 plus 3, that gives me 0. If I say -100 plus 100, that gives me 0. So I am going to add 0 to these expressions so that it doesn't change anything, but I'm not going to use the number 0. Instead, I'm going to add something to this -1 that will make it become -3, and add the other part to this such that it will become the same number minus the same number plus the same number, which equates to 0. So it's going to change the values, the look rather, but it's not necessarily going to change the value of this fraction. Okay, so which number will I introduce to -1 that will make it become -3? That number is -2. So that means I am going to bring in minus 2 plus 2. So minus 2 will be introduced to this one, plus 2 will be introduced to this one. And when you have performed this operation, you would have actually been adding just 0. So it doesn't change the value. So minus 1 minus 2 gives you minus 3 over 3 plus, so now plus 2, if you add it to 0.8451, you get 2.8451 divided by 3. So this is easy, we still get -1 because minus 3 over 3 is minus 1. But now let's do this on the calculator. So we have 2.8451 divided by 3. So that gives us 0.9484. So let's wipe this off. Remember, this is simply our rough work. So we have this to be, so you have your bar 3 over 3, that is 1, that's minus 1, plus, so your 2.8451 over 3 gives you 0.9484. So when you bring this together, this one naturally goes to the characteristic part when you add it. So that becomes bar 1.9484. That is the result of this division. And that's why we told you that when it comes to logarithms of numbers less than 1, it requires a more technical approach. More technical, but easy. So now we can easily perform our subtraction. So 2 minus 4 is not possible, so we take 1 from here, it becomes 12. 12 minus 4 gives us 8. And here you have 5, you take 1 from here, 15 minus 8 gives us 7. So 13 minus 4 gives us 9. And here you have 9. 9 minus 9 gives us 0. And now if you take away 1, we took away 1 from 0. So 0 minus 1 gives us minus 1. Okay? So we now have minus 1 minus minus 1, which means minus 1 plus 1, which is 0. So our final answer here, still in the logarithm section, is 0. So we now have to find the antilog. We have come to the end of this operation, but we now have to find the antilog of this one. And finding the antilog of this number is very easy. So this is not negative. So looking for the antilog of this is easy. It doesn't have a bar, it doesn't have a negative. So all we just do is punch this into the calculator. And so if you find the antilog of 0.0978, that's going to give you 1.2526. So that's 1.2526. And that's the answer. I'm going to explain some other things later, like how we came about this division here. I'm going to give some examples where I will just specifically explain how you can manipulate that, and even how you could add and subtract from a bar, especially if you are borrowing from a bar or you're borrowing from 0. So I'll explain that later. In the meantime, we're going to stop here for now. See you next time.